Welcome, my friends! A polynomial is a term or the sum of two or more algebraic terms whose variables have whole number exponents. For example, 3x squared plus 7x plus 4 is a polynomial with three terms. The terms are 3x squared, 7x, and 4. The expression 10x plus 3 times the square root of x is not a polynomial, as the square root of x is the same thing as x to the 1/2 power, and only whole number powers are allowed for polynomials. Also, expressions with transformations of variables, such as logs, constants raised to variable powers, and trigonometric functions are not classified as polynomials. Polynomials are classified by the number of terms that they have. Polynomials with one term are called monomials, such as 4x to the 6th power. Polynomials with two terms are called binomials, such as 3y squared plus 7. Polynomials with three terms are called trinomials, such as 10x to the 5th power plus 4x plus 1. Polynomials can have more than three terms, but we generally do not have a special classification for them if there are not 1, 2, or 3 terms. Polynomials are typically written in what is called standard form, which means the exponents on the variable decrease from left to right. For example, 3x plus 8x squared plus 4 is not written in standard form. The exponent on 3x is 1, the exponent on 8x squared is 2, and the exponent on 4 is 0. The expression can be reordered as 8x squared plus 3x plus 4, so that it is in standard form. The degree of a polynomial is the highest exponent on any of the terms. For example, the degree of 3x to the 7th plus 5x to the 3rd plus x is 7, as the highest power on any of the terms is 7 on 3x to the 7th. More often than not, polynomials only have one variable, but if there is more than one variable, the degree takes into consideration the power on all variables. So, for example, the degree on 3a to the 5th, b to the 4th, plus 7ab to the 2nd, plus 9ab is 9, as the combined power of all variable exponents is 9 on the 3a to the 5th, b to the 4th term, as 5 plus 4 is equal to 9. That's larger than the combined power on any of the other terms, which is 3 for the second term and 2 for the third term. What do you think the degree of 9y to the 4th, x to the 3rd, w, plus 2, minus w to the 3rd, y to the 5th, plus 6x to the 9th is? Well, our first term has a degree of 4 plus 3 plus 1 is equal to 8. Our second term has a degree of 0, since there aren't any variables at all. Our third term has a degree of 3 plus 5, which is 8 again. Our final term has a degree of 9. The highest combined exponent count on any of our terms is 9, and therefore we say the degree of the entire polynomial is 9. The leading coefficient of a polynomial is the coefficient on the first term when the polynomial is in standard form. For example, the polynomial 5v minus 20 minus 4v squared minus 20v to the 7th is not in standard form. We can rewrite the polynomial in standard form as negative 20v to the 7th minus 4v squared plus 5v minus 20, so that the powers on our variable decrease from left to right. Our first term is negative 20v to the 7th, which is sometimes called the leading term. The leading coefficient is the constant in front of the variable on the leading term, which in our example is negative 20. Additionally, the degree of this polynomial is 7, as that is the highest exponent on any of our variables. Polynomials can be added by adding like terms. So for example, we can add 3t squared minus 5t plus 1 plus negative 2t squared plus 6t plus 4 by matching up the like terms. 3t squared plus negative 2t squared is equal to t squared, as adding a negative is the same as subtracting. Negative 5t plus 6t is equal to, well, just t. And 1 plus 4 is equal to 5. Altogether, we have t squared plus t plus 5. We can also subtract polynomials. Take, for example, x squared plus 3 minus 5x squared minus 2x plus 7. The easiest way to subtract polynomials is to switch the sign on each term of the polynomial being subtracted, and convert the problem into an addition problem. So doing that here, we have x squared plus 3, and then instead of minus, we have plus negative 5x squared plus 2x minus 7. All I've done is change the minus sign in the middle to a plus sign, and then change the sign of each of the terms in the second polynomial from negative to positive, or vice versa. Now we can add term by term. X squared plus negative 5x squared is equal to negative 4x squared. We only have one term with x's, which is 2x, and is added. And then we have for our constants, 3 plus negative 7, which is equal to negative 4. Altogether, we have negative 4x squared plus 2x minus 4. We can add or subtract more than two polynomials, such as with negative 8v squared minus 4v plus 1 minus negative 3v squared plus 2v plus 2 plus 6v squared plus 8v minus 3. First, let's change the subtraction sign between the first two polynomials to an addition sign by switching the sign on each term in the polynomial. Here is the result. Simplifying the v squared terms, we have negative 8v squared plus 3v squared plus 6v squared, which is equal to, well, just v squared. Simplifying the v terms, we have negative 4v minus 2v plus 8v, which is 2v. And simplifying the constants, we have 1 minus 2 minus 3, which is equal to negative 4. Our final answer is v squared plus 2v minus 4. Let's try one with more than one variable. We have 7x squared minus 5x squared y plus x plus negative 6x squared y plus 3. The idea is exactly the same, but you can only combine terms if they have the exact same exponents and are raised to the exact same power. We only have one term that has x to the second power, which is 7x squared, so we can list that first. Notice these two terms both have x squared y as their variable combination, so we can combine them. Negative 5x squared y plus negative 6x squared y is equal to negative 11x squared y. We only have one x and one constant term of 3, so we can just copy those down. Altogether, we have 7x squared minus 11x squared y plus x plus 3. We can also divide polynomials by monomials, such as with 24u to the third plus 6u squared plus 13u, all divided by 3u. More frequently, you will see this written out like this, on a numerator and denominator. We need to divide each term by 3u, and then put them back together to get our final answer. So this problem can be simplified to 24u to the third over 3u plus 6u squared over 3u plus 13u over 3u. For the first term, we know that 24 over 3 is equal to 8. For the u's, recall that when variables are divided, we can subtract the exponents in our simplification. So u to the third divided by u is the same thing as u to the 3 minus 1 power, since u by itself is u to the first power. That simplifies to u squared. 6 over 3 in the second term simplifies to 2, and the u term simplifies to just u, since 2 minus 1 is equal to 1 when we subtract the powers. The constants in the last term can't be simplified, and the u's cancel each other out, so we are left with 13 over 3. Altogether, our answer is 8u squared plus 2u plus 13 over 3. Let's try a division problem with multiple variables. We have negative 15x to the fourth y to the seventh plus 24x to the fifth y to the third plus 9x squared y divided by 3x to the third y squared. Just like before, split this up into 3 separate fractions, each with a denominator 3x to the third y squared. Here is the result. The process is the same as last time, except we have 2 variables to keep track of this time. In the first term, negative 15 over 3 is equal to negative 5. X to the fourth over x to the third is x, since 4 minus 3 is 1 when you subtract the exponents. And y to the seventh over y squared is y to the fifth, since 7 minus 2 is 5 when you subtract the exponents. For the second term, 24 over 3 is 8, x to the fifth over x to the third is x squared, and y to the third over y squared is y. For the last term, 9 over 3 is just 3, x squared over x to the third is x to the negative first power, and y over y squared is y to the negative first power. Now, you might remember that it's desirable to write our final answer without negative exponents. To do that, we can rewrite x and y from our final term in the denominator with a positive exponent of 1. So our final answer is negative 5xy to the fifth plus 8x squared y plus 3 over xy. All right, my friends, that completes our introduction to polynomials.